Good afternoon, everyone. This is Vinay working as a maths programmer associate in Avanti Fellows. Today, I'm going to teach you the topic maxima and minima extremes of a function in the application of derivatives, which is the local maxima and local minima. And once completion of the local maxima and local minima, we will discuss the global maxima and global minima. Okay. So this is very important topic in the application of derivatives chapter. Okay. So everyone, please be active here. I'm going to share my screen. I think everyone can see my screen. Yes, I've given a homework yesterday, the topic increasing functions and decreasing functions. How many of you have did it? Anyone has done it or not? Like how much it is rate is increasing and decreasing. Guys, I launched the poll. Uh, Please give the poll, everyone, whether my voice is clear or not, and whether you're able to see the screen or not, guys. Just check it. Good afternoon, YouTubers, everyone. Good afternoon, Bhargav. Guys, everyone, please try to complete the poll. In the meantime, give me the answers for the homework I've given yesterday. Guys, anyone has tried it or not? This is like this kind of questions will be asked in the JEE mains here. Good afternoon, everyone. Okay, good afternoon, Hari Prasad and Naika. Guys, try to stay active. Chalo. So this kind of questions will be asked. Yesterday we have discussed this kind of question, right? Like I think we have discussed regarding that cone, right? The cone problem we have discussed. So why no one is giving the answers, guys? Come on, tell me how to solve this question. This is an easy question. That is why I've given it as a homework here. Okay. So I need answers. Anyone has done the question? Anyone has tried it at least? Okay, I know that you guys are having unit test. Unit test is happening for you in JNVs. Okay, I can understand. At the same time, you guys have to focus on the JE mains also, guys. Please, it will be a definitely difficult thing for you, but you have to do hard work, guys. Okay, then only we can get the success right. So everyone, please listen to the class very seriously and be attentive. Okay, yeah. See, so what is the question he has given? Okay, rate of change. The question is coming from the rate of change. Okay, this kind of questions will be asked in the IIT JEE. I'm telling you again and again. So what is the thing he has given here? We just check it. Are is this a difficult one? Just look at here, everyone. What he has given here has given a iron ball. Okay, a ball. Take a ball of radius. How much? Of radius it is 10 centimeters. Is it okay? Yeah, it is 10 centimeters. And what is saying, it is coated with a layer of ice of uniform thickness. Means this ball has another layer having which is coated with the layer of ice, and having a thickness how much here? Means another layer it is having. This ball is having another layer which is having a thickness how much? He has given. Okay, it is having some thickness. So what is the question he is asking, and what is the things he has given in the question? See, I have already told you by solving the rate of change questions, guys. Have you remembered it or not? What you have to 3 points I think I have told you. First thing is what is the question? Rate of what he's asking. That is first thing. Second is what he has given. What he has given, which rate he has given. Understanding or not? And it comes to the third one, what are the variables he has given, what thickness or else radius, you have to apply it, which each and everything will be what I have to yesterday. Do you remember or not here? 1/3 pi r square, if you have done it, every term should be if you're having 2 or 3 variables, each and every all variables should be converted to single variable, and then you have to differentiate. Everyone remember it or not here? Actually, I think we have converted that h into r or r into h, r equal h by 6, something he has given in the last class. Everyone remembered it or not? Okay. So means what I'm telling you is each and in the given formula, whatever volume you take, okay, in that formula you have to convert all the variables into a single variable, and then you have to differentiate it. Okay, guys, everyone remember? Okay. Now tell me what is the question is, what is the, what he has given here? melts at a rate of 50 centimeter cube per minute. Usha has given the answer. Very good, Usha. Your answer is correct. Very good. Hariprasad is correct. Yeah, very good. Yeah, guys, tell me, guys, please listen to me very carefully. It's a very, very important question here. Okay, this kind of questions will be asked for damn sure. It is very easy questions. That's the reason you please listen to me. The melts, what you say, what is given? It is melting at the rate of 50 centimeter cube per minute. By looking at the units, you can say it right. Okay, which units you can say? What are the means what he has given? Which rate he has given? Guys, can anyone please help me? Is it decreasing of radius or what? Come on, tell me, guys. Come on. Very good, Naveen. Very good. Your answer is correct, Naveen. Guys, come on, tell me. Guys, please check Suraj. It is not increasing of radius. Why? Because what is given here melts at the rate of centimeter cube. If you are saying cube, cubical of some units, what is the meaning of this one? Very good, Bhargav. What is the meaning? I need answers here. Come on. Everyone try to stay active, guys. Come on, tell me. Very good, Ashit. Yeah, exactly. It has to be a volume here. If you're having some centimeter cube or meter cube, it's something but volume, hai na? So what is the thing he has given? Volume, dV by dt, rate of the volume, rate. Anything, okay, very good, Rajama. So volume rate means with respect to T, you have to measure, hai na? dV by dt. So dV by dt, what he has given? That melts at the rate of. See here, if a ball is melting means it will melt in all the directions, na? So obviously your volume is getting reduced. Okay, guys. So dV by dt is equal to 50 centimeter cube per minute. That is the thing he has given. Okay, this is the first point what we have learned. Means what he has given that we have to write it down. Okay, that is first thing. What is the second one, guys? Second one is what is asking how at the particular rate how much thickness when the thickness of the ice is 5 centimeters. Means thickness is 5 centimeters. At that particular time, what is asking? Then at the rate at which the thickness of the ice is decreasing. Okay, he's asking the rate at which the thickness is decreasing. Guys, can you tell me the thickness is reducing? It means it's nothing but the radius, right? If the complete radius, what is the complete radius? You have to take it as 10 plus 5. Do you agree or not? Means the inside radius plus thickness. So your new radius will be how much? 15. So how much rate the whole radius is reducing? That will be a rate your thickness is getting reduced. You agree or not, guys? Come on, tell me. Now tell me what is the volume? What is the volume of the? What is this one here? Is it a circular sphere? Obviously, it is a ball here. Ball means sphere. Everyone knows it. So can you tell me what is the volume of the sphere, guys? You guys have clarity or not? See, volume of the sphere, volume of the cone, all these things you should have clarity here. Okay, because it will be helpful in mathematics as well as in the physics also here. Okay. Come on, tell me what is the volume of sphere? Don't confuse here. Okay. Ashit, constant is some small mistake is there. Ashit, Naveen is correct. Others, very good. Bhargav. Others, come on, tell me here. What is the volume of sphere? I'm waiting for 10 seconds here further so that at least 10 students will answer. Guys, come on, try to give the answer. Even it is a wrong answer, please try to participate. Okay. Like those who participate, I definitely appreciate those guys here. Seriously, I'm telling you. Come on, tell me what is the volume of the sphere? Very good, Naika. Correct. Yeah. So volume of the sphere is nothing but very good, Ashit. Very good. Excellent here. Excellent. This is how you have to participate here, Ashit. Very good, Ashit. Yeah, so see, what is the volume of the sphere here? It's something but 4/3 pi r cube. Okay, why are you taking this much of time here? Okay, 4/3 pi r cube. Now tell me, what is dV by dt? What is dV by dt? 4/3 into pi. Okay, into what is d by dt of 4/3 pi is constant here. Okay, and r cube is the variable here. So what is the thing you have to do? So that is equal to 4 pi by 3 into what is d by dt of r cube, guys? Come on, tell me. It is nothing but 3 r square. See here, variable is different. So you have to differentiate the variable again. 3 r square into dr by dt. Is it okay, everyone? Guys, getting clear or not? Come on, tell me here. So ultimately, what is the thing you got? dv by dt is equal to, thank you, Ashit. For 3 got cancelled here. Okay, so 4 pi r square into dr by dt. It's okay, guys. Come on, tell me. Yeah. So as we are considering the thickness inside our radius, so what is happening here? What is dv by dt? Already dv by dt has been given, right? How much it is? 50. Okay. So it is 50 is equal to 4 pi. What is my new radius? Actually, r has to be r1. R new has to be taken as r plus thickness here. Okay. Thickness if I take delta x like that. Okay. No need of taking all these things. I'm just telling you directly in a simple way. What is the new radius? It is nothing but 15, right? Very good, Ashit. 15 whole square into dr by dt. Dr by dt is same as our how much the radius is getting decreased. The same rate the thickness is also getting decreased. Guys, everyone understanding or not? So what is finally dr by dt is equal to 50 by uh, 4 pi into 225. Okay. So how much it is? So I think with 25 I can do it, right? With 25, how much? 25 twos are and 25 nines are, I think so. Yeah, very good. So it is 2 ones and 2 twos. So what is the ultimate? What is it? 1 by 18 pi. You got dr by dt. It is same as what is the how much the radius is getting decreased. It is same as d. If you take thickness also by dt. Okay, so your answer is 1 by 18 pi, which is option B. Everyone understood or not, guys? Come on, tell me. Guys, those are given the option B is correct. Guys, you understood or not? Then we'll move on to the maxima and minima. Guys, please give me confirmation. This kind of questions will be asked. It is very, very easy questions only. Only thing what I'm telling you again and again is write the volume formula or else surface area formula, whatever formula he is asking. That formula you write it down and just you do differentiation. Okay, with respect to what he is asking. With respect to that, you just differentiate it and make sure that in that formula everything is converted to single variable. Okay, that is very, very important point, guys. Okay, in the last class I told the same. Yes, understood or not? Come on, please tell me. Local maximum and minima is like very easy, like very easy and good concept here. Okay, so before going to the inside of the local maxima and minima, I just want to make sure everyone knows the concept of increasing and decreasing functions. In the I think last class we have discussed the increasing and decreasing functions, right? Come on, tell me here. If the function is increasing, okay, means what I'm trying is, guys, for increasing from now onwards, for increasing I'm why to write all the time. We are increasing. I'm just notating it like this arrow, upward arrow, guys. Okay, remember everyone. And decreasing, I'm just representing it as downward arrow. Please remember it. Okay. So now tell me what I'm trying to say is, whenever your function is increasing, then what can you say? Then what can you say, guys? Whenever your function is increasing, what you have to say? Come on, tell me. In the last class, we have discussed what happens to his first derivative. Very good, Rajamma. Guys, others, tell me, come on. If function is increasing, yeah, what happens to slope? Slope is nothing but derivative, first derivative, f dash of x. What happens? Come on, tell me here. This is very, very important. I'm telling you guys. It will be helpful throughout the whole chapter. Okay, throughout the chapter, it will be helpful. The function is increasing. What happens to the first derivative of the function? Come on, please tell me. Very good, Naveen and Gautam. So f dash of x has to be greater than 0. Okay, greater than equal to 0 also you can take. If I'm just take it as strictly increasing, guys. Okay, from now on, I take that strictly increasing. Okay, yeah. Okay, everyone. So when function is increasing, f dash of x is greater than 0, and a function is decreasing, then what you have to say? It is nothing but f dash of x is less than 0. It's nothing but slope na yaar. F dash of x is, see, here it is increasing, then its slope is also increasing na. Understanding or not? And the function is decreasing, its slope is also decreasing or not? Then all the function will get decreased. Okay. So what is my intention is, everyone has to remember this box. Very important here. These 2 points I will ask you again, guys. I'm telling you, while teaching this local maxima, local minima, it will be helpful for you again. So this one is very important. Function is increasing, f dash of x greater than 0. If function is decreasing, f dash of x is less than 0. Everyone has got clarity on this or not? Come on, tell me. Everyone? Clear, na? Clear, right? Okay, thank you, thank you. So, you will have two derivative tests, okay, guys? Guys, I just want to ask you one thing. Have you heard, like in your CBSE or anywhere, already you have what is a local maximum, local minima is there in you have studied it already? You have some idea, or this is the first time you are listening? You have some idea? Local maxima and minima. You have some idea, right? Very good, very good. Let's, have you heard first derivative test and second derivative test? Two derivative tests will be there, okay? 90% we always use the second derivative test, but you guys have to know what is the first derivative test also. You guys have to know it, okay? Okay, Bhargav, very good, very good. So some idea is there, right? Very good, very good. So I will what you say, whatever doubts you are having, I will completely clear it, okay? Don't worry. So listen to me properly. I will do it fast on you, okay, guys? Come on, tell me. Properly we will do it, don't worry. Come on, tell me. First we'll discuss the first derivative test. Okay. Before going this first derivative test, second derivative test, don't worry by looking at these names here. Okay. Guys, do you know what is local maximum and local minimum? You know it or not? Come on, tell me. What is local maximum? Means uska matlab kya hai? What is the meaning of it? What is your intention? If someone is saying local maxima or local minima, hai na? Like some curve is there, guys. Okay, some curve has been given to you like this. Okay, you will be having so many points on this curve. If you want to say it is point A, point B, point C, point D, point E, and F. Is it okay? Okay. Now tell me, what are these points? Guys, come on, tell me, what are these points? Like A, B, C, D, E, F. What are these points? Can anyone please tell me? Well, you can just don't think yet. Don't think much. I have drawn a diagram. Okay. And I'm asking you, what are those points? Very good, Naveen. Very good, Ashit. Yeah, it is like in the like you see, like you can just look at here, everyone, guys. It is a maximum point. Point A is a maximum point. Point B is somewhat minimum point. Means you can't say for the whole curve it is minimum. You only have to say for this region, my point A is maximum. Means for that local, my point A is maximum. And if you see here, for this region, my point B is minimum. Understanding or not, guys? Means for that local. Understanding or not here? In that area, if you take this point C, for this local, for this area, my point C is maximum for this area of the curve. Okay, for that curve I'm talking about, guys. Okay, yes, here I understood or not? So this is how you got here. Okay, it means for any curve, okay, you are having some maximum like hill points. Okay, kind of hill. So wherever your curve is turning, okay. So if it is like what I say reverse of the V, then you should have to say it is maximum, it is minimum. So local maximum and local minimum points. Guys, clear or not? So these are called as. Means I'm just telling you guys. Means I'm trying to understand you. First of all, what is the local maximum, local minimum? All the time you will say. So what is it? That I'm trying to understand to you. Okay, local maxima and minima. Guys, come on, tell me. Is it okay? Clear, na? So now tell me, at the same time, I'll tell you the global maxima also. Can anyone tell me what is global maxima? Global means what? For the whole curve. For the whole curve. Global means for whole curve. Global maxima is what? And global minima is what? Which point? Come on, tell me. It is like a small game here, okay? Which one is global maxima? Can't you tell? Guys, come on, tell me. Which one is global maximum? Which means highest peak. Highest peak for the whole curve. Okay, no issues, Rajama. Just listen to me. What is global? I'm telling you, global is nothing but the when compared to in whole curve. If you by looking at the whole curve, means you have to like see, you have to look for this whole region. In this whole region, what is the maximum point and what is the minimum point? Is it okay, guys? So global maxima is nothing but point A, है ना? Very good, guys. Soman has given the answer. So it is point A. And what is global minima? Guys, what is global minima? Very good, Srujan, Naveen, Ashit has given the answer. Rajam, Srujan, Rajamma, very good. Ashit, Usha, very good, Surat. Very good, guys. And here YouTubers, Ramkrishna Reddy, yeah, correct. Aparna, Priyanka, very good. Bhargav, correct. Very good, guys. Come on, keep it up. Yeah, tell me. Yeah. So what is the global minima? Obviously, the least point is point E. Okay. So this is what we are like. This is how the what to say the topic is. Okay. So this is the background of the topic. You understood or not? First of all, what is it? What is it? If I'm saying some local maximum point, if I'm saying talking about some local minimum point, what it is for the given curve like that. This is how it looks here. Okay. For any given curve, I'm talking. Guys, clear or not? Local maxima, local minima, global maxima, global minima. So this is how, what is it? I told you. How to find it? Now I will tell you. Okay, guys. Okay. Till now I have told you. It's like this is this and this is this. Okay. Now I'm going to explain you how to find it. Okay. If some, if what is it? If some question has been given, he will ask you what is the maximum point for this curve. What is the minimum point of this curve? Like that he will ask. Okay. How to solve it? Okay. Rajamma, you can't say local and global are same. Local means for the particular region, Rajamma. Global means for the whole curve you have to see. How to find, I will tell you. Finding local maximum, how to find global maximum and minima, I will tell you, Rajamma. Understanding or not, Rajamma? Yes, everyone understood now? So now tell me. Okay, see. Give me confirmation. Yeah, thank you. So see, guys, okay, the first derivative test and second derivative test are two types of tests which scientists has been found for finding the local maxima and local minima. Okay, so this is one way, and that is one idea. This is one idea, that is one idea. Okay, both are more or less similar, but always second derivative is the very easiest one to find. Second derivative. But what is first derivative test? Is it okay? I'm telling you, guys. Can I start, guys? Can please tell me? Come on. First derivative test. Okay, listen to me properly and seriously, guys. Okay, see, first derivative test, what is the idea behind this first derivative test? I'm telling you. Okay, so if I'm taking some like this, okay, some curve is like this. Okay, what is this point here? You guys already know. Point A is global maxima, but how to like what could be the condition? Okay, this is some f of x, guys. Okay, function f of x ka graph hai. Okay, guys. So can anyone tell me like wait? I'm taking 3 points, guys. Okay, I'm taking 3 points. A curve starting one point A, and this is point C. I'm taking, and this one is point B. Guys, come on, tell me. In my function means it is A, C, B function. Okay, guys, everyone understanding or not? Now tell me, like AC for the curve AC, what is happening to my? Come on, tell me what is happening to my function? What is happening to my function? Then later I will ask you the derivative. What is happening to my function, guys? Is it increasing or decreasing here? AC I'm talking about. F of x is increasing. Okay. So what can you say, guys? Come on, tell me. You have to say f dash of x is greater than 0. Very good, guys. Very good. So now tell me for CB what is happening? Come on, guys. Tell me. For CB, what is happening? F of x is decreasing. For CB, I'm talking CB. F of x is decreasing. Then f dash of x is what is happening? It is less than 0, right? You agree or not? Excellent, guys. Very good. Yeah, very good. Surag, Ashit, Naveen, Rajamma. Very good, guys. Keep it up. Gautam, Viresh. Yeah. Correct, Amit, yeah. So you guys understood what I'm trying to say. So now listen to me properly. So here what he's saying is, for maxima, okay, for maximum we are talking here. Yes, note it down. Like you just remember maximum I'm talking. Then we will go on to the minimum. See what is happening. Guys, give me 1 minute. Try to think about the local minima also. Yeah, guys. Sorry for the disturbance here. Yeah, I will tell you, Rajama. At points, I will tell you. So look at here. I'm trying to tell one thing, guys. My voice is clear, right? Yeah. So from point A, for the curve AC, it is increasing. For curve CB, it is decreasing. है ना? Now, can anyone tell me at the point C what is happening? What is happening to my function? It is like a constant, right? At the point is maximum point. Guys, sorry for the it is there has been technical error. Guys, my voice is clear or not now? Guys, my voice and screen, everything is clear or not? Can you please give me reply? Yeah, my screen is visible, right? Okay, thank you. Thanks for the confirmation, guys. Thank you so much, Rajama, Ashit, and Prithvi. Ramakrishna, Hariprasad, Lakshmi, thank you. Yeah, see, okay, guys, okay. So, sorry, there was an internet connectivity issue in between here. Okay, see, okay, I can hear everyone. So, what I'm trying to say is, okay, thanks, bro. So, see, guys, what I'm trying to say, guys, for a local maxima, just simple, very simple, please listen to me once. Local maxima, before the local maxima, my function is increasing. At that point, see what is happening? After the maxima, it is decreasing. At that point, see, can I say my function is constant? So can I say what is the derivative? F dash of x will be equal to 0. If I draw a tangent here, it will be a straight line or not? If I draw a tangent, it will be a straight line or not, guys? Come on, tell me. It will be parallel to x-axis. You agree or not here? Yes, come on, tell me. Guys, please give me confirmation. So these are the 3 points I would like to discuss. These are the only 3 points. If you once understood these points, everything will be very easier. What I'm trying to say is for local maxima, before the local maxima, your function is increasing. So f dash of x is greater than 0. At that maxima, f dash of x is equal to 0. After the local maxima, it is decreasing, increasing, constant, and decreasing. Is it okay? Okay, na? Very good. So now tell me. So what I'm trying to say is first derivative test says that okay, at local maxima or minima, can I say my first derivative will be 0? f dash of c is equal to 0 now. Just now I proved at that particular point my derivative will be 0 or not. Come on, tell me. Guys, come on, tell me here. Can I say f dash of x is equal to 0 at my local maxima and minima? है ना? At that particular point, my f dash of x is equal to 0. But see, my question is, okay, my question is, I have given you some curve like this, okay? If you do f dash of x is equal to 0, you got x equal 1 and x equal to 3. X equal to 1 gives you point A is x equal to 1. Okay, this is x equal to 1 and this is x equal to 3. But at point A you are having maxima and point B you are having minima. Now you tell me how to find which is maximum, which is minimum. You are getting 2 points, guess. Okay, you're getting if you're doing see, till now you understood that sir, for local maxima and local minima, first derivative will be 0 because your maximum point, your tangent will be parallel to x-axis. So first derivative of the function will be 0. Then if you equate it to 0, then you will get x values, some values, x equal 1, 2, 3, something. Now my question is, at x equal 1, 2, 3, so where you will get maxima and where you will get minima? How you will know? Understanding or not, guys? Guys, did you understood my question or not? See, this is how you have to think here, okay? Very good, Naveen. Your answer is exactly correct. So, for this, scientist has given us two things, first derivative and second derivative. So, first derivative, what it is saying is, guys, come on, tell me, simple logic, it is maxima and this is minima. Na? So, you will get at x equal to some point C, okay, from point C, okay, here point C. So, what you will do for first derivative? Some C minus H you take, C minus H and C plus H, 2 points, like before C and after C. If you find out f dash of x, here what happens to my f dash of x? What you say if I take x like C minus H, f dash of C minus H, it has to be greater than 0, na? You agree or not? Before point C, it will be greater than 0, and f dash of C plus H will be less than 0. Like it is increasing, then you are getting f dash of x is greater than 0 and less than 0. Then you have to say it is maximum. Guys, understanding what I'm saying or not? So here if you do f dash of C minus H means some nearer to like H I'm taking, guys, okay, nearer to C only, left side, then it has to be less than 0 because it is decreasing, the curve is decreasing for minima, and f dash of C plus H, what is happening, it is greater than 0, then it is this is the condition for minima and this is the condition for maxima. I will give you example also, don't worry. Guys, my intention you understood or not? For see, second derivative test is very, very important. The first derivative we never use it here, we never use it, but you have to know it, okay? Anywhere it might be helpful for you guys, okay? So what is the, guys, I'm repeating it again, please listen to me carefully. What I'm trying to say is, first point for checking whether at which point you will get local maximum minima, first thing is you have to do local maximum minimum for first derivative is always equal to 0. Then what you will get, you will get x equal to something, you will get critical points, okay? Those are called as critical points, guys. This is one thing I would like to tell you. So what are the like local maximum and local minimum, each and everything together called as critical points, guys, okay? At critical points only you will get local maxima and local minima, okay? Guys, everyone understanding or not? Here point A, B, C, these things are called as critical points. At these critical points you will have maxima value or minima value. Is it okay? Guys, I'm repeating it again, please listen to me. The first thing is you have to do f dash of x is equal to 0, then you will get x equal to some values. Is it okay? Those are critical points. At those points you will have either maximum or minimum, kuch bhi ho sakta hai. So what you have to do, if you take x equal to 1, the previous one it is f dash of c minus h is greater than 0, and right side it is left side it is greater than 0 and right side less than 0, means increasing and then decreasing, then it is maxima. Or else left side it is decreasing, right side it is increasing, then it is minima. No, it is if second derivative test fails, then we will take first derivative. Yeah. If second derivative test fails, you can just check the first derivative test, obviously, Priyanka. Okay. So first you have to know both the things. Okay, I will tell you what happens if it fails also. Okay, after explain the second derivative test. Okay, point of inflection, all these things you will get, Priyanka. Okay, guys, this one you understood or not? First derivative test. Then I will move on to the example. Guys, please tell me. ultimate final conclusion is this one, this thing. First derivative is equal to 0. You do it first derivative, whatever question he has given, f dash of x equals 0 here. Then you will find x equal to some values. So before that values, if it is greater, increasing and decreasing, then it is maximum. Decreasing and increasing, it is minimum. Clear a first derivative. I will give you one example here. Please give me confirmation. Yes, come on, tell me. Clear or not? Guys, come on, tell me here. Guys, please try to give reply. Okay, that is very important. See, teacher is shouting and explaining. I want confirmation. इसलिए confirmation मांग रहा हूँ कि the only reason I'm asking confirmation is so that I can move on with a satisfaction that each and every student has got understood. Okay, try to give confirmation here. Okay, thank you. Thanks for the confirmation, Naveen, Rajamma, Amit, and Sujan. Yeah. So this is the first derivative test case. Okay. So here are some, what to say, the theory for which I have explained right now, guys. Okay, you can look at it in the notes. So this is the question. Okay, before going, this is not regarding the first derivative test. See, guys, don't use the concept of any first derivative or nothing. Can you please tell me, by looking at this function, can anyone tell me what could be the maximum value? Okay, and what could be the minimum value? What could be the maximum value? What could be the minimum? Don't use any first derivative and don't do f dash of x. By looking at the f of x only, don't do f dash of x. This is just a basic question. Means it allows us to think. Okay, it helps us to think. See, you can say, sir, you can't find the maximum value. Like here, I'm telling you, in f of x, you can't find can't say. It is infinity. You can say, okay. But what is the minimum value? I'm asking. Like that here also. Can't say, could be the, I'm telling you. What? Okay, one by one we will go here. Come on, guys, tell me. 2x minus 1 whole square plus 3. Array, it is always a positive one, na? So it always, for x, if x is goes on increasing, your f of x also goes on increasing, na? So it is infinity. So maximum value will be infinity. You can't say. What is the minimum value? This one you can say it right. What could be the minimum value, guys? Come on, tell me. What could be the minimum value of the first one? First one. Because what is the least value of this whole square? Whole square is always positive. What could be the least value? It is 0. So what is the minimum value? 0 plus 3 is 3. Very good guess. Very good. Excellent guess. Excellent. Naveen, Ashit, very good guess. Very good, Sujan. Excellent. Excellent. Suraj and Rajama. Correct. Correct. Understood, na? So what is the minimum value? It is 3. Okay. Here, what is the maximum value? Yes, come on, tell me. Can you tell what is the maximum value? Guys, please look at there. Negative symbol is there. What is the maximum value? This x minus 1 whole square is always positive only. X minus 1 whole square is always positive only. And into negative. So it is, this term is negative term. When can you get maximum value? When this negative term is equal to 0, right? Very good, Rajamma. Suraj, check your answer. What is the maximum value? Guys, maximum, Ashit, minus infinity is the least value, na? I'm asking maximum value. Like if you take number 3, 3 is greater than minus 10. Ashit, understanding or not? Yeah, x could have any values, yeah. Both of them. X could have any values. You can take any values, yeah. Any value, I'm just asking the maximum value. Any values you take, you will have the maximum value as 10 only, because this whole thing is negative term, na? So at x equal to 1, you will get 0. At x equal to 1, you will get 0. Whenever this negative term becomes 0, that will be your maximum value or not? Very good. Rajama is correct. Surak is correct. Ashit is correct. Naveen, yeah, correct. So what is the minimum value? Guys, what is the minimum value? Can anyone tell me what is the minimum value for a minus x minus 1 whole square plus 10? What is the minimum value? Can you say? Very good. It is like it goes on, it could be minus infinity, yeah. It goes on, negative value is there, na? So as x goes on increasing, x minus 1 whole square is goes on increasing, and negative minus of x minus 1 whole square goes on increasing. Understanding or not? So you can't say. So what are the problem here? By without using the application of derivatives, can you say what are the maximum value and what are the minimum values for the given functions? It will be difficult, right? You can't say. Everyone understanding or not? Guys, understanding what I'm saying? Please tell me. And it will be like very like so that is where our application derivatives, this first derivative, second derivative comes into takes place. Okay, guys. So this is one example of proving it. Okay. So this is what he is saying. Okay, minimum value and maximum value is given because maximum minimum you don't know, guys. Okay. Yeah. So this is the first derivative test, guys. What which I have explained till now. First, guys, I'm revising it again. Once listen to me. Critical points. What are critical points? Whenever first derivative is equal to 0, then what are the points you will get? Those are named as critical point. Like this is the critical point, and this is the critical point. Okay, like that. These are the critical points. Point B and point C are critical points, guys. Okay, and here see f dash of x is greater than 0, and here f dash of x is less than 0. Okay, like that it is going on. So it is the curve is increasing here, and curve is decreasing. This everything everyone knows it, right? Okay. So here, when like a point of inversion is there, that I will explain to you. Okay, now here is the example: x cube minus 6x square plus 9x. Come on, tell me. X cube minus 6x square plus 9x plus 15, I think so, है ना? Guys, come on. First of all, what is the first step here? I'm telling you, first step is find critical points. All the time. This is the very important point. Find a critical point. How you'll get it? F dash of x is equal to 0. You do it. And second one is check for local maxima or minima. This is the two steps here, basic steps. Now tell me what are the critical points, guys? Guys, I need the critical points, everyone. I'm switching on the timer also. How many critical points you are getting? Come on, tell me. Come on, tell me, guys. How many critical points you are getting? No need of saying how many critical points. What are the critical points? What are the critical points you are getting? F dash of x is equal to 0. You have to do it, guys. Okay, I'm giving you 2 minutes of the time. Come on, do it fast. After getting the critical points, those who have completed it, try to check at which point maximum will get, at which point local minima you will get. Sir, if we have nth degree polynomial, then maximum number of critical points is n minus 1. Yeah, obviously, yeah. Obviously, Bhargav, because you are having like nth degree polynomial, then you have to do the first derivative, right? You have to do the tangent that cuts you 1 degree, Bhargav, then gives you n minus 1 degree. So maximum number you will get n minus 1. Is it correct? It is correct, Bhargav. Understood or not? Guys, come on, what are the critical points? I need answers here. Come on, tell me. Guys, don't do silly mistakes. Everyone try to give the correct answer. Priyanka, Ramakrishna are correct. Hariprasad, check your answer. And here, who has given the answer, guys? Come on, Naveen is correct. Srujan, check your answer. Danush, you tell it the maximum value or what here, Danush? Ashit, is it the critical point you are saying or any value? So I'm asking critical points, guys. Okay, x I'm asking. I'm not asking f of x. At that critical points, you will have f of x means maximum value and minimum value. I'm not asking the value. I'm asking that at which point you will get maximum minimum values. Okay, guys. Try to know the difference between the point and the value. Ashir, check it. Rajamma is correct. Chinmay, yeah, two critical points. What are those critical points here? Very good, Chinmay, correct. Ashit, correct. Okay. And Nabeen, okay, Nabeen has given it also, very good. Okay, guys, so we will look at here, okay, we will just look at it. By using the first derivative, I will just solve it. First derivative is not that good here. The second derivative is very what to say, very excellent one. Second derivative is okay. So now tell me, what are the critical points? So what I have to do first? Tell me, guys, come on. F dash of x is equal to 0. I have to do. What is f dash of x, guys? Can directly you can write it down, right? D by dx of the f of x. Na? If you differentiate with respect to x, what you will get? X cube. It is 3x square minus 12x. है ना? 6 to 12x plus 9 is equal to 0. Very good, Nabin. Very good. So if you can just take 3 common, so what you are getting? X square minus 4x plus 3 is equal to 0. So you can just remove the 3. It will, if it just goes on to the 0 by 3 is 0 only. So inside one, how can I write x square? The splitting method, everyone knows it, right? It is minus x minus 3x plus 3 is equal to 0. So x of x minus 1 and minus 3 of x minus 1 is equal to 0. So ultimately, what is the thing you have got? The quadratic equation you have splitted, x minus 1 into x minus 3 is equal to 0. So what are the critical points, guys? Come on, tell me. Therefore, my critical points are x is equal to 1 comma 3. Guys, listen to me once, everyone. Don't get confused. These are the points. These are not the values. Okay. If you substitute this point in f of x, then you will get the maximum value and minimum value. Okay. If sometimes he will ask you like this, guys. Guys, listen to me. He can ask you two type of question. One type of question is at which point you will have maxima, local minima. That is one question. Then this is the answer. If he's asking what is the local maxima value, he's asking, then what you have to do? Like if at a point 1, if you are having maxima, then f of 1, substitute 1 in f of x, then that is the value. Yes, understanding or not here? If a curve has been taken, this is the point, and y-axis will be your value. Okay, guys, remember that point. Okay, in question the pronunciation is very important. He's asking point means the critical points. He's asking the local maximum value, then f of x you have to find. Clear na? Okay, x equal 1 and 3 I got. So now how to check whether at a point 1 I will get a maximum or a point 3 I will get a minimum or where whatever it is. Okay, how to check it, guys? Some students might think, sir, I will just substitute x equal to 1 and 3 inside my function. Guys, can you do it like that? Like if I get f of 1 is greater than f of 3, then this is maximum and this is minimum. Can you do it like that? Guys, you can't do it here. You can't check for both f of 1 and f of 3 because, guys, I'm telling you one simple example here. Okay, one simple example. Look at here. Never ever get mistaken that maxima is always greater than minima. Guys, come on, tell me. If I tell it could be, if I tell this could be the point 1, okay, point 1, and this is point A and B. This is point 3. X equal 1 and 3 you got na. See here, what to say? This is f of A na, f of 1, and this is f of 3. Understanding or not? See here, minima at point B is greater than maxima at point A. Na? It could be happen or not. Guys, minima can be greater than maxima also. Here we are talking about region, local region. In its local region, it is minima, but it could be greater than maxima also. Understanding or not, guys? What I'm trying to say, guys? Understanding or not? Please tell me. For any critical point, you can take here, Dhanush. If it is a cubical, like it is cubical equation, na? For cubical equation, you will do derivative. Then it will be quadratic equation. Then you will get two critical points. Okay, if you are having quadratic like power 4, f of x is equal to power 4, then if you do derivative and equal to 0, you can have 3 critical points. Dhanush, 2 critical points can be same also. Dhanush, understood or not? Darush, please give me confirmation. Okay. So till now, I got that x equal to 1 and 3 are my critical points. Now tell me how to find at what you say my f of 1, x equal 1 is maxima or minima, or f of 3 is maxima or minima. Come on, tell me how to check it. Guys, come on, tell me what is f of x first of all. I'm trying to write f of x here again. Once again, f of x is equal to x cube minus 6x square plus 9x plus 15. Nah? So what I'm trying to prove is at x equal to 1, I'm checking first one. Okay. Guys, tell me, like, can I say 0 less than 1 less than 2? Can I say? Guys, do you agree? Guys, do you agree? So I'm trying to check what you say f dash of x, right? We have to check f dash of x. What is f dash of x we got? See what I have told you in first derivative test. F dash of x is for maxima. For maxima, f dash of x greater than 0 and less than 0 means increasing and decreasing. Like that you have to check, na? And for minima, it is less than 0, decreasing and then increasing. Like that you have to check. Okay. So now what is f dash of x, which you already know? 3x square minus 12x plus 9. Hai 3. So it is nothing but I will just remove the 3. X square minus 3x, sorry, 4x. It is 4x, na? X square minus 4x plus 3. Okay, guys. Now tell me, guys, come on, tell me, f dash of 0, what is happening? F dash of 0? F dash of 0, how much you are getting? Can anyone please help me? How much, guys? F dash of 0, I'm getting. It is 9. You agree, na? Very good, Suraj. And what is the other one I'm trying to do? See, I'm trying about 1 year, okay? One cup before 0, 1 after 2. F dash of 2, how much you are getting? Come tell me. It is greater than 0. You know, greater than 0, na 9. F dash of 2, how much? 4 minus 8 plus 3. So how much I'm getting here? So it is minus 3 less than 0. Guys, now can anyone help me? At point 0, my f dash of x is increasing. Okay, it is increasing. And at point 2, okay, at point 2, my f dash of x is less than 0, means it is decreasing. So at x equal to 1, what can I predict? Is it maximum value or minimum value? Can anyone tell me? At x equal to 1, whether I am getting local maximum or minima? So x equal to 1 gives you local maxima. Okay. Similarly, try to find for x equal to 3 also. X equal to 3. 3 is lying between. 3 is second one, x equal to 3. 3 is lying between 2 less than 3 less than 4. We have to check for f dash of x. F dash of x is equal to 3x square minus 12x plus 9. Na? So it is nothing but 3 into x square minus 4x plus 3. Now tell me, I think f dash of 2 we have to find, na? F dash of 2, how much? Already we have find it out, right? It is minus 3, right? Na? Yeah, I think f dash of 4 is how much? F dash of 4, 3 into 16 minus 16 plus 3. F dash of 4, I think I am getting 9 here. Is it correct? Okay. So f dash of 2 is less than 0. F dash of 4 is greater than 0. Now tell me here, for x equal to 3, what is happening? Can anyone please help me? For x equal to 3, what is happening? For x equal to 3, I'm talking. So for 2, it is less than 0. It is decreasing. And for 4, it is what it is happening? It is increasing. So at point 3, is it maxima or minima? Guys, come on, tell me. At point 3, it is maxima or minima, guys? It is local. Whenever you are saying, try to say local here. Okay, local minima. Okay, understood, everyone? Very good, Naveen, Ashish, Suraka, Praveen. Very good, guys. Very good, very good. Guys, clear? First derivative समझ में आया ना? It is very bit lengthy, na? Like you are checking for 2 points, checking here and there, everything, it is getting difficult or not. That is why we'll move on to the second derivative, which is very, very easier. It will take 1 minute of time. It will take 1 minute, 20 seconds of time here to solve it. Yes, first derivative understood or not? Yes, please give me confirmation here. Only thing is critical points you have to find. After that, you will take two values left and right side and check. Two values left and right side, like that you have to check. Is it okay, guys? So this is the slide, okay? This is how you have to do it. Guys, everyone understood the first derivative test clearly or not? Come on. I will go to the second derivative test, which is the one and only important thing which we have to solve all the time. Okay, the example I will solve it later. I would like to discuss about the second derivative test. Okay, guys, I think local maximum minimum second derivative test I'm talking about now. Okay, local maxima and minima, which is very, very important. The second derivative test is the only way you have to solve the problem all the time. Second derivative test. Guys, I think you already have some idea, na? You have some idea, not? What are the conditions for local maxima and what are the conditions for local minima? See, one thing you already know all the time. F dash of x is equal to 0. Everyone agree or not? Always f dash of x is equal to 0. Second derivative means in the name itself it is there. We are using the second derivative for saying whether it is maxima or not. For local maxima, my condition is f double dash of x is less than 0. For local minima, f double dash of x is greater than 0. So this is the condition. How you have got it, I will explain. Okay, I will explain the proof. Don't worry. This is the table you have to remember all the time, which is very, very easier. If you remember this small thing, then complete it. That's it. This is maximum minima. That's it. What are the two conditions here? First thing you already know. First derivative with the same thing. This it doing till critical points is same here. For first derivative, for second derivative, solving till critical points, finding critical points is same procedure. After that, you have to do double derivative here. Okay. Yes, understood or not? Yeah, I will tell you, Dhanush. Now I am going to explain that only. Why we got f double dash of x less than 0, f double dash of x greater than 0. How I got it? Okay, by graph only I will tell you. Okay, Dhanush. Guys, you first of all tell me this condition. You have understood the condition for local maxima. Your condition is f dash of x is equal to 0. You have to by heart it here. This is very, very important. You have to by heart it. For local maxima, the condition is f dash of x is equal to 0, f double dash of x is less than 0. For local minima, f dash of x is equal to 0, f double dash of x is greater than. For minima, you will get double derivative greater than. For maxima, you will get double derivative less than. Opposite, it will be opposite, guys. Okay, why it is so? Why you got like this? I'm going to explain now. Clearly. I will just take 5 minutes of your time and I will explain you. Okay, come on, tell me, guys. First, we will discuss about the local maxima. Okay, I'm talking about local maxima, guys. Come on, I need help of each and every one of you. Okay, local maxima I'm talking about. Okay, if I draw if I have taken a graph like this, it is a local maxima. Do you agree or not? This is maxima case, na? Point A, B, and C. Is it okay? So I'm taking three things here for maxima. First one is AC, and next one is at point C, and next one is CB. Means throughout the whole curve I'm talking about. Whole curve ACB, what is happening for the curve? And that is what I'm talking about. Okay, guys, come on, tell me now. Can anyone please help me? What is happening to my f dash of x? This you already know. What is happening to my f dash of x? Come on, tell me. At AC. At AC, my f dash of x is what? Can anyone tell me? I've already told you I need your help. Come on, tell me. See, function is increasing. I'm talking about derivative. You have to say greater than. Okay, Praveen. Don't get confused. You should not say f dash of x is increasing because function is increasing. Your f dash of x has to be, guys, what it has to be? It has to be greater than 0. Okay, na? Don't get confused here. Function is increasing. Okay, or else I will, as some students are getting confused, first I will write function. Okay, function f of x क्या हो रहा है? Increasing, increasing, and constant, constant, and CB it is decreasing. Now tell me, ठीक है? अभी बताओ. Now f dash of x is what is happening? It is, can I say greater than 0? And this one is equal to 0, and this one is less than 0. Guys, this one everyone understood or not? If you understand this, it will take 1 minute for me to explain. This you understood or not clearly? है ना? What we have studied till now. This is the thing what we have studied till now. Come on, tell me. Now tell me. Now I am asking, sir. You have drawn, f of x, and you have proved for f dash of x. See, can I say? See, guys. What can I say is, see, guys. So I'm telling you. My f dash of x is also a function, na? Is also a function or not? Guys, do you agree or not? My f dash of x is also a function. If I take my f dash of x as some g of x, and if I able to prove g of x is increasing, then what can I say? Then g dash of x is greater than 0, na? Guys, do you agree or not? If I am able to prove my g of x is increasing, then the derivative of g of x is greater than 0. Do you agree or not? Means understanding my logic you are getting understood or not? F dash of x is also a function. If I prove that this is increasing, then what I will prove? Double dash of x is greater than 0. If it is decreasing, then I can say f double dash of x is less than 0. Understood? So ultimately, what is the thing you have to prove here? Before you have proved f of x is increasing, decreasing, constant f of x. Now I have to prove my f dash of x, what it is happening. Guys, now I'm talking about local maxima. Can anyone tell me, by looking at this table, whether my f dash of x is increasing or decreasing throughout the function? Throughout the function a, c, b, throughout the function a, c, b, my f dash of x is increasing or decreasing? By looking at this table, inside the yellow one, by looking at that, you can say, I'm just waiting for smart answers. I can directly tell, just I'm waiting. What is my question? I'm repeating it again. Throughout the curve local maxima a, c, b, what is happening to my f dash of x? Is it increasing? Value of f dash of x, it is increasing or decreasing? Guess simple logic here. It is like a simple, like a game, na? Simple logic. Okay. What I see, look at here. Guys, look at here, guys. F dash of x is what is happening here. First it is greater than 0, and then it is equal to 0, then it is less than 0. Means positive, 0, and negative. Means what it is happening? Positive, 0, negative means what it is happening here? My f dash of x is decreasing, na? You can just say my slope is increasing, 0, and then decreasing. See, ultimately positive to negative it is going on. So f dash of x is decreasing. So you can say it or not. Come on, tell me, guys. Guys, logic understood or not? Very good, Naveen, Rajamma, yeah, Dhanush, very good, very good. Understanding or not, Ashit? Guys, my logic understood or not? I'm repeating it again. For my local maxima, I'm talking about. For my local maxima. Okay, bro. No issues. Guys, come on, tell me. For local maxima, what is happening to my f dash of x? It is positive, and it is 0, and it is negative. Na? So it is positive, 0, negative means what it is here. If I draw a curve for my f dash of x, what can I say? If I draw a curve, it is goes on like this, na? Like for first it is positive, and then it is 0, and then it is something, it is negative. Na? Guys, understood what I am saying? So for local maxima, can I say my f dash of x function is decreasing or not? Guys, for local maxima, positive, 0, negative. Positive, 0, negative. So it is my f dash of x is decreasing. So ultimately, what I am trying to say, for local maxima, my f dash of x is decreasing. So if f dash of x is decreasing, what can I say? F double dash of x is, means any function is decreasing, what happens to its derivative of the function? Guys, come on, tell me. I need answers here. I need answers. Come on, tell me. Very good, Dhanush and Ashit. Come on, guys. Come on. If my one function is decreasing, what happens to its derivative? Is less than zero. Its derivative is less than zero. Guys, I've told you in the first time, na. If f of x is increasing, then f dash of x is greater than zero, na. This is what I told you in the starting of this today's class. Guys, understood or not clearly? I will again explain for the minimum also. This you understood or not? Come on, tell me. Guys, come on, tell me, guys. Guys, come on, tell me. Okay. I will explain for the minima, Rajamma, so that you can understand clearly. Clearly, na. So what I'm trying to say is, here for maxima, I'm again repeating. Was look at here for maxima, Rajamma. Look at here. My function is increasing, constant, and decreasing. That you know, function is increasing, constant, decreasing. So f dash of x is greater than zero and equal to zero and less than zero. F dash of x. So positive, zero, negative. So you can say f dash of x is decreasing. If f dash of x is decreasing, its derivative is less than zero. So what is the condition for local maxima, guys? F double dash of x is less than zero. This is how you got the second condition. Understood or not? Come on, tell me. Guys, please tell me you understood or not. Now I'm repeating for local minima. Those who have some clarification, listen to me. Okay, guys. Okay, small clarification you might need, na. So listen to me. Local minima, guys. You only those who understood, try to help me, guys. Okay, local minima here. Local minima. Okay, so it will be like this, na. It will be point A, point C, and point B. Okay. Now, chalo, we will form a table. Come on, tell me. For AC, at C, and for CP. Now tell me what is happening to my f of x, guys. What is happening to my f of x for AC? Don't get confused between increasing and greater than zero, guys. Okay. No, Hariprasad, there will be no local maximum minimum for a straight line. It will, because the slope is itself, it is zero here. Each and every point will be a local maximum minima. Guys, come on. F of x is very good, guys. Very good, guys. Excellent. F of x is AC, it is decreasing. It is constant. At C, it is constant. My function, I'm talking about function. At CB, it is increasing. Is it okay, guys? Very good, Navin, Rajam, Surak, Praveen. Keep it up, guys. Come on, tell me. Help me. F dash of x, first derivative. Guys, first derivative kya hoga? If f of x is decreasing, its derivative will be less than zero. Negative, na? So it is less than zero. If f of x is constant, for any constant, if you derive, the f dash of x will be equal to zero. And for CB, what is f dash of x? It is greater than zero. Very good, guys. Very good. Clear, na? So now tell me what is happening to my f dash of x. Now tell me what is happening to my f dash of x for ACB. Throughout ACB, what is happening? Negative and then zero and then positive. Means it is going from negative to positive. Means what can I say ultimately? What can I say, guys? Tell me. F dash of x is increasing. This is what I can say throughout ACB. If f dash of x is increasing, what can I say for double derivative? Therefore, f double dash of x is greater than zero for local minima. F double. Guys, clear? Huh? Guys, clear or not? Clearly, I've explained. Na? Everyone understood or not? Come on, tell me, please. Clear, na? Very good. Thank you. So ultimately, this is the table. So everyone understood the table or not? If you solve 2 or 3 problems, na, you will just do like this here. It is very easy. So I'm just ultimately, what are the things to be remembered, guys? Very good here. Thank you, everyone. So what are the things to be remembered? These are the things to be remembered. Those are the proofs here. Okay. What are the things to be remembered for local maxima and local minima? For all problem solving, these are the things to be remembered. What is the first point? What is the condition? f dash of x is equal to 0 is your first point, guys. F dash of x is equal to 0, first point. Here also same, na? For minimum also same condition. First point will be same because finding critical point is same, na? Then you will get x is equal to critical points. You will get. Remember this point here, okay? X is equal to critical points. We will get. And now, what is the second point, guys? What is the second condition for local maxima? Please tell me what is the second condition. Guys, come on, tell me. F double dash of x. F double dash of x. What happens to my double dash of x for maxima? Tell me. For local maxima, what happens to my double derivative, guys? Come on, guys. Very good, guys. Very good. Ashit, Dhanush, Naveen. Yeah, very good, guys, Naveen. So it is negative. It is less than 0. You should say less than 0. For local minima, what is the condition? F double dash of x is greater than 0. So these are the things you have to remember for local maxima and local minima. Understood? Huh? So just take this as like a table. This is very, very important, guys. Okay. Please remember, everyone. This is like very important thing to be remembered. Telling you again and again, guys. Okay. Yeah, Hari Prasad. If you take tan inverse of x, there will be no maximum and minimum value. You will get a point of inflection. I'm going to tell. So, see, there is no such rule that for all functions you should have a local maxima, local minima. For some functions, there will be neither local maxima, neither local minima. Understanding or not, Hari Prasad? There is no such rule that for all the functions you should have the local maxima and local minima. There is no such rule, guys. Okay. Guys, everyone understood the condition or not? Now can I move on to the example? Come on, tell me. So this is the condition here. So what you say? What can I say is what you say? If I say f double a point of inflection, if you guys look at here, everyone, I will just show you the point of inflection. Yeah, whenever f dash of x is not changing, like guys, look at here, everyone. Like if I take a condition, if I take a curve like this, something like this. Okay, here what is happening? If you take something, any curve like this, here it is goes on increasing, na? Guys, come on, tell me, everyone. So there is no such point like this hill kind of thing. It is not there. So here also for point, look at here, everyone. For point AB, for your what is say f dash of x is greater than 0, f of x is increasing, and for point B, for basic curve also, f of x is increasing and f dash of x is greater than 0. Understanding or not, guys? Come on, tell me. So point B, you are neither it is the f dash of x is not changing its curve. If I say f dash of x is positive and then negative, then it is like this, na? Then maximum you will get. And f dash of x, you are getting negative and then positive, then you will get minima, guys. Okay. So if I say f dash of x is positive and positive, what can I say, or negative and negative, what can I say? There will be no maximum or no minimum. So this will be the case of point of inflection. You call it as a point of inflection, guys. Neither maxima nor minima. Okay, everyone. Everyone understanding or not? What about f of b? F of b is a constant. Now f dash of x, you can just say it is 0. Okay, if it is a constant curve, Suraj, then you can say for derivative it will be 0. Understood or not, Suraj? But but unless and until he has given that it is like a constant, it is parallel, you can't say it. Suraj, you understanding what I'm saying or not? For local maxima and minima, you can say there exists a point where your derivative will be equal to 0. But for this kind of thing, you can't say, Suraj, like understanding or not? Suraj, can you please tell me? Okay. It depends on the question here, okay? Yeah. So everyone, point of inflection, here you can look at, this is the slide he has given. Whenever f dash of x is doesn't change, then it is point of inflection, means neither local maxima or neither local minima case. Okay. Guys, everyone clear? See, guys, I'm telling you again and again. This table is very important. This table, local maximum, local minimum. This table is very important, guys. Okay. So whatever I explained just now, he has given in the with the notes. Okay, so now we'll go on to the see global maximum, global minimum already we completed at night. So how to solve the question? I will just tell you. Come on, I think he's asking the global maxima. Okay, just leave it. Guys, come on, tell me. First of all, for this given question, everyone try to solve this question. I need what are the critical points, guys? Come on, tell me. What are the critical points? First of all, we will solve step by step, guys. Okay, guys, come on, tell me what are the critical points. Okay, thank you, Hari Prasad, Aparna, thank you. Guys, come on, tell me. Guys, come on, you have my students are very fast. I know it. Come on, guys, tell me. What are the critical points? Fast. Tomorrow I will bring more and more problems also. Today, just we will complete this problem. Come on, tell me here. What are the critical points, guys? How we will get the critical points? F dash of x is equal to 0. Come on, guys. Come on, tell me. What are the critical points you are getting? D by dx of x cube plus 6x square plus 3 is equal to 0 you have to do. So how much you are getting? Come on, guys. Come on, give me the answer. Okay, you need the question. Find both the maximum and minimum value of x cube plus 6x square plus 3 in the interval minus 7 comma 3. Guys, this interval part, just leave it. That interval part for that is helpful for global maximum minimum. That I will explain you. First, just leave the interval part. If he has not given, I'm modifying this question as find the local maximum value and local minimum value for this given curve. Okay, I've just erased the interval. Interval I will tell you later. Okay, what is the local maximum value and local minimum value of x cube plus 6x square plus 3? At which point you will get critical point? That you tell me first. Okay, Naveen has given the answer. Ashit, I think you have to check it here. Aishwarya, okay. Okay. Chalo, okay, guys, listen to me once, everyone. Very good, guys. Guys, look at very good. Bhagavav, Ramakrishna, Hari Prasad, Aparna, very good. Priyanka, excellent. So, for finding local maximum or minimum value, first you have to find critical points. Huh? Come on, f dash of x is equal to 0. How much? So you're getting 3x square plus 12x plus 3x square plus 12x plus okay 0 na is equal to 0. So how much you are getting? I have taken 3 common, so it is x square plus 4x is equal to 0. So 3 to chala gaya, 3 is gone. So ultimately you are getting x into x plus 4 is equal to 0. So what are the critical points you are getting? X equal to 0 comma minus 4. So these are the critical points you got, guys. Everyone has got the same or not? Those who have said 0 comma minus 4 is correct here. Very good here. So 0 comma minus 4 is correct, guys. So these are the critical points. Now come on, tell me, guys, how can I check at which point I'm getting local maximum, which point I'm getting local minimum, guys? Come on, tell me. Can anyone tell me how can I check it? How can I check it here? Guys, what is the local maximum, local minimum? Second condition. Very good, Naveen. What is the thing you have to do now? What is the second condition here? What is the second point? Double derivative. Very good, Ashit. Hai guys, double derivative you have to do it or not? What is the first derivative value? Just take the first derivative value first. It is 3x square plus 12x. Hai so now you tell me, guys, listen to me very carefully. Now you tell me what is double derivative? F double dash of x. Guys, come on, tell me. 6x plus 12. Now tell me at x is equal to 0, what is my double derivative value? Guys, come on, at x equal to 0, what is my double derivative value? I need answers, guys. Come on, tell me. It is 12. Very good, guys. It is positive or negative? It is greater than 0. So at x equal to 0, what can you say it is? Local what? Maxima? It is minima. Greater than 0 means minima, guys. Na? So similarly, find for another point. What is another point, guys? At x equal to -4, I think so. What is my value of f double dash of x? I think it is minus 24 plus 12. It is minus 12, na? So it is less than 0. So at x equal to -4, you will have what? You will have what? Which one? Very good, guys. Very good. Very good, guys. Everyone, super. It is local maxima. So I understood. So what can I say ultimately? At x equal to 0, you will have local minima, na? And x equal to -4, you will have local maxima. So what is the local minima value? Guys, what is the local minima value? If I ask you value, what you have to do? Local minima value is nothing but it is f of 0. How much it is f of 0? Guys, come on, tell me. So you have to substitute the critical point. Then only you will get the value, guys. Okay. F of 0, it is 0 plus 0 plus 3. So your local minima value is 3. And what is your local maxima value? Local maxima value, guys. Come on, anyone? Any answer? Very good, Suraj. If f double dash of x is equal to 0, you have to say neither local maxima, neither local minima here. Point of inflection. Usha, understanding or not? That is what point of inflection. F double dash of x is equal to 0. Usha, understanding or not? So local maxima value, what is the local maximum value? F of -4. How much? -4 whole cube plus 6 into -4 whole square plus 3. It is 64, I think so, na? -64. Plus, I think 16 into 6, right? 60 into 16 plus 3. 64 plus 32 is 96, I think so, na? -64 plus 96 plus 3. How much it is, guys? Come on, tell me. 70 means 26, 30. And it is that 26 and 4, 30. 33 and 3. How much you are getting? 99 minus 64. It's nothing but, I think, 35, right? Yeah. Everyone has got the answer. Very good. Yeah, very good. Someone has given the answer. Naveen, Usha, very good. Suraj, very good, very good. Yeah, you can't. X square is a point of inflection. Like that, you can't say. Who like x square? Why you are saying it is point of inflection, Hari Prasad? Your curve is decreasing and then increasing, Hari Prasad. So why you are saying it is point of inflection? If f of x is x square parabola, your curve is decreasing and then increasing. Then it is like you can say, na, why you call x square? It is minima. You are having minima at x equals 0. You will have local minima. Hari Prasad. Yes, understanding or not? Guys, local maxima value is 35. Local minima value is 3. Again, tomorrow I will bring some new questions so that pura clarity aa jayega. Everyone understood or not? So ultimately, this is the table I want everyone to be remembered here. First derivative is equal to 0 and double derivative will be less than 0 for local maxima. Double derivative will be greater than 0 for local minima. Understood or not? Clearly, guys, come on, tell me. Okay, any doubts? I think some question is there. Okay, what to say? Guys, local maximum, you got clear the idea, na? So this is the conclusion. First derivative equal to 0. If you do, you will have the critical points. Guys, finding critical point is the first point. Second thing is local maxima and local minima. How you will get it? A double derivative. If double dash of x is less than 0, it is local maxima. F double dash of x is greater than 0, it is local minima. Guys, clear or not? Local maxima and minima extremes of a function. Tomorrow I will give one example for global maxima and global minima, and then when we will complete the tangent and normal topic, tangents and normal, which is very easy one. That this is what somewhat complicated, but that is very easy. Guys, clear? Guys, everyone understood clearly or not? Anyone is having any problem? Please let me know in the chat box. Come and tell me. Guys, clear or not? Come on, please tell me. Thank you, thank you. Everyone, I launched the poll. Everyone give the feedback of students class, guys. In the meantime, anyone can ask me the doubts here. Okay, Hariprasad, what you're saying for double derivative? So for double derivative, yeah, exactly, Aparna. Hariprasad, for that x square, f of x is equal to x square, Hariprasad, your double derivatives will fail. But by what you say, if for double derivative is failing, what you have to do? You have to go for first derivative. Well, that is what you have told in starting in the class, right? If you take the first derivative, by looking the first derivative test, you can just tell that you will have a minimum value for f of x equal to x square. Understanding or not, Hariprasad, what I'm trying to say? Double derivative is zero, even though by using the that is why whenever double derivative is sometimes whenever double derivative is getting failed, you will go on to the first derivative test. That is when our first derivative test will be helpful for us. These are some exceptional cases, guys. Hariprasad, understood or not? Hariprasad, can you please give me confirmation? See, who told you if you get critical point is equal to 0, it is neither increasing or not decreasing? No. You can't say like that, Hariprasad. F dash of x greater than 0, less than 0 means what you're at x equal to 0, you're telling na at x equal to 0, your f dash of x is less than 0 and f dash of x is greater than 0, right? Okay, yeah. Guys, everyone try to give the feedback of students last year. Complete the poll, please. Come on. Guys, if anyone is having any issue, please let me know. Guys, come on, tell me in the chat box. Please always feel free to talk with me, guys. I think there will be no such condition that if you are getting both, if both test fails, then obviously there will be no maximum and no minimum case here. It is neither maximum nor minimum case. You have to say like that, Priyanka. Okay. If you are like Hariprasad has said that if you like double derivative failed, then you go for first derivative test. If first derivative is success, then you can just say maximum or minimum value. Okay. If both fails, then you can't say it is neither maximum nor minimum. Okay. Just clear, everyone? Clear na? Any doubts? Okay, everyone, study well, practice well. Any doubts, please let me know. I will definitely help you guys. Okay. All the best for the unit test, guys. Okay. Study well and practice well, guys. Okay. Take care, everyone.